Okay, send my screen. All right, so in the previous lecture, we have discussed the definition of econometrics, and we know that regression analysis is a common tool in econometrics to help us investigate or to understand the relationship between variables. So today we will spend more time on discussing what regression analysis is and how it can help us to understand the relationship between variables. Okay, so let's start with the definition of regression analysis. So regression analysis concern, okay, we care about, we want to know the dependence of one variables in the model that we call it the dependent variables on one or more variables that we call the independent variables or the explanatory variables. In order to estimate the value of the dependent variables, the mean of the dependent variable, the conditional mean of the dependent variables, when we know the value of the independent variables. Okay, so let's draw a figure or draw a map to see the relationship between the variable here. Wait a minute. So last time when we talk about the methodology of econometrics, we have I have shown you the that called the model in econometrics. Okay, we have two components in the model, that is variables and parameters. Parameters are constant, but variables has different value in different circumstances. So here, for the variables, we will also divide the variables in two categories. The first one is the dependent variables, or we call it the explained variables. And the second category is the independent variables, or you can call it the explanatory variables. Okay, so we have two types of variables in the model. Okay, we have two types of variables in the model. We have dependent, okay, dependent variables, and we have independent or explanatory variables. All right, so in one model, you only have one dependent variables, okay? This one dependent variables, but you can have one or more independent variables in a model. All right, in the model that we will study later, we usually name the dependent variables y variables, and we call the independent variables the x variables. Okay, so regression analysis. In regression analysis, we want to know the dependencies of dependent variables on the independent variables. Or in other words, we want to know how the independent variables affect the value of the dependent variables. Okay, we want to know this relationship. We will try to find out how the independent variables affect the dependent variables. And what is the purpose of that? From this, we will want to estimate, okay, sorry, we want to estimate, okay, the value of y, or the conditional mean value of y, Okay, we want to estimate the value of y or the conditional expected value of y when we know the value of x. Okay, when we know the value of x, that is regression analysis. We care about the dependence of dependent variables on the independent variables. Okay, and the purpose of that is to estimate y or the mean value of y when we know the value of the independent variables. Okay, and for example, we have some example here. Uh, we want to know the dependence of quantity demanded on the price level of a good. Okay, we can say that we want to know how the price level of a good affect the quantity demanded of that good. All right. We want to know the how personal income affect personal income. In other example, we want to know how capitals, labor, and technology affect the output of enterprises, for example. All right, so that is linear regression analysis here. Okay, we want to know how the independent variables affect the dependent variables, right? Um, for the dependent variables, okay, so the name of those variables have explicitly tell us the role of those variables in the model. Okay, so dependent variable or the explained variables, its value is explained by other components in the model. All right, and for the independent variables, so the role of S in the model is to explain for the value of the dependent variables. So that's why we call it independent variable or the explanatory variables. All right, and because it is independent variables, the role is to explain the value of dependent variables, and the value of independent variables does not depends on the things inside the model. When you bring the independent variables into the model, its values must be fixed or known. All right, it must be known before you bring it into the model. So it means that the value of those independent variables depends on other things outside the model that we investigate. All right, so that's why we also call it the exogenous variable. Okay, and for dependent variables, because the value of it depend on the other components of the model, like the independent variables, then we call it endogenous variables. Okay, but the names that mostly used for our variables are the dependent variables, independent variables, explain variables, and explanatory variables. Okay, sometimes we can call it regressions or regressors. Okay, dependent variables is regressions and independent variables are regressors. All right, dependent variables are the response variables, and independent variables can be called the stimulus factor as the stimulant variables. Okay, so here we have some example of dependent variables and the corresponding independent variables. For example, here we have, if we care about, we want to explain, okay, we want to explain the value of quantity demanded for a good, for example. Okay, so what are the independent variables that we can use to explain the value of quantity demanded? Okay, so how can we find those independent variables? You have to look back Remember that for the econometrics methodology, the first step that we have to do is to do a review, a thorough review on the topic. Okay, so from those from economic theories and from the result of previous researches, you can find the independent variables that we can bring into the model to explain the value of the dependent variables. For example, in this case, when we want to explain the value of quantity demanded, we can use some independent variables like the price of that good or the income of consumer or other goods price. Okay, some the or sometimes the price level also. Okay, or the number of consumer in the market or something like that. Okay, we base on the economic theories and the results of previous researches to determine the independent variables that we use to explain the dependent variables. Okay, if you want to explain the value of crop yield, okay, you can use some independent variables like the temperatures or the level of rainfall, the level of sunshine, and the volume of fertilizers that used for the crop. Okay, and for consumption, okay, if consumption is the dependent variable, then we can use some independent variables like income, wealth, personal needs, and age to explain the consumption of individuals, for example. Okay, so remember that you cannot determine the independent variables by yourself. You have to base on economic theories. You have to base on the results of previous researches to determine the independent variables that we use to explain the value of the dependent variables. Okay, all right. To get a better understanding of regression analysis, let's make the difference. Okay, let's show the difference between some different type of relationship. Okay, firstly, when we discuss the difference between statistical relationship and deterministic functional relationship. Later, we will discuss the difference between regression and causations, and finally, the difference between regression and correlation. Now, first, the difference between statistical relationship and deterministic relationship. So, deterministic relationship or the functional relationship is the type of relationship that we usually see in mathematics. Okay, so for one value of the variable x, okay, we have only one corresponding value of variable y. Okay, as we say, this relationship is often seen in math or in science, like physics or chemistry. Okay. For example, we have a function like this. We have a function y equal 3 times x. So when x equal to 1, y only equal to 3. Okay, when x equal to 0 and y is exactly 0. So for one value of x, you have only one corresponding value of y. That is the deterministic relationship. Later in our econometrics model, there's also a deterministic relationship between some components of the model. Okay, and I will show you that relationship later. All right, but now let's remember that deterministic functional relationship mean that for one value of x, okay, we have only one corresponding value of the other variables. Now, different from deterministic relationship, we have statistical relationship. So statistical relationship mean that for one value of x, you will have you have many corresponding value of the variable y. Okay, for example, with one price level, you will have different quantity demanded for different markets at different points in time or something like that. Okay, so with one level of income, for example, 8 million dong per month, then the expenditures of each individual is different. Some may spend 4 million dong per month, some may spend 5 or 7 million dong a month, and some people when even spend 10 million or more, 10 million dong a month, for example. Okay, so for one price level, for one level income, different individual may have different level of consumption. Okay, so that is, we call the statistical relationship. And the relationship, as you see, the relationship between economics variables are statistical relationship. Okay, because in fact, in reality, there's a lot of there are a lot of factors that affect the value of one variables. Okay, so when we explain the value of that variables, if we want to determine the exact value of that variables, you have to have all the other factor. Okay, all the factor that affect the value of that variables, and you have to have the data, you have to have the value of those all variables. Okay, but it is quite unrealistic in reality. Okay, so that's why the relationship between economics variables are all statistical relationship. Okay, and in our econometrics model, okay, I have shown you that. All right, econometrics model allow the statistical relationship between variables. Okay, all right. Next, let's make show the difference between regression and causations. So as you see in this figure, okay, so the relationship between the dependent variables and the independent variables here is a one-way relationship. Okay, one-way relationship. That means we want to know how the independent variables affect the dependent variables. Okay, but causation is a two-way relationship. X affect Y, and Y also affects the value of X. Okay, so that's why regression does not imply causation. Although regression assumes a causes relationship between the variables, that is a direct link, a direct cause and effects link between the variables. However, this is only a one-way relationship. Okay, causations means a two-way relationship. Later, when you study the subject forecasting in economics and business, you will see that we will do causality test between the variables to see whether x affect y and also y affects the value of x. Okay, but in this course we study regression analysis, and the purpose of regression analysis is only a one-way relationship. Okay, how the independent variables affect the dependent variable and not the reverse. Okay, for example, here, when we study the dependence of econometric scores on the score in math, okay, on your score in math, your score in econometrics depends on your math score at high school. As you see, econometrics when involved, there's a lot of things in when you study good, when you do well in math course, then you can also okay, you will have a chance, a higher chance in doing good, obtain a good grade in econometrics. But however, if you get a high score in econometrics, it doesn't mean that had had a high score in math. All right. Maybe because you spend more time on doing the exercise, maybe because you spend more time on following the lectures. So you understand better you understand econometrics better. Okay. And maybe your math score is not very high, but you still have a high score in econometrics. Okay. All right. For example, another example is the relationship between crop yield and rainfall. So rainfall, okay, affect the crop yield, but the crop yield does not affect the rainfall. Okay. So in regression analysis, we only care for the a one-way relationship, a one-way relationship that how the dependent variables depends on the independent variables, okay, not the other way. All right. So regression does not imply causation. Causation is a two-way relationship. Okay, when you see the value of x, okay, when you see the value of x, you can predict exactly the value of y, and when you see the value of y, you can in turn predict exactly the value of x. Okay, but regression analysis do not have that. Okay, next we will show the difference between regression and correlation. So in when we review statistic and probability, we have discussed about correlation analysis. So for correlation analysis, we just care about the variations, the uh, variation of two random variables at the same time. Okay, whether they move in the same direction or whether they move in the opposite direction. Okay, so we only look at the value of those variables, and we will show the correlation between them. Okay, we only base on the statistics to analyze the correlation relationship between them. But for regression analysis, it's different. Okay, so let's see the difference between them. The first one, regressions concern with the dependence of dependent variables on the independent variables. Okay, but for correlation, we only want to know the strength of the linear association between two variables. In correlation analysis, we do not say that X has an effect on Y or Y has an effect on X. Okay, but with regression analysis, we want to show that whether X affect the value of Y. All right. Okay. In correlation, we do not say that X affect Y or Y affects the value of X. Okay, but in regression analysis, we want to prove that whether X has an impact on Y. All right. For regression analysis, we have two types of variables in the model. We have dependent variables and independent variables, and their role are different in the model. Okay, as we have discussed, the independent variables, the value of independent variable is explained by the independent variables. Okay, the independent variable has a role to explain the value of the dependent variables. But for correlation analysis, the variables are treated symmetrically, which means there's no difference between the role. Okay, there's no difference in the role of two variables. Okay, in regression analysis, we have dependent variables and independent variables. Dependent variables is a random variables. Okay, and then we want to estimate the value of it. But for independent variables, okay, independent variables, as we see, when we bring the independent variables into the model, their value must be known, okay, and their value must be fixed. Then independent variables is not a random, okay, are not random variables. They are fixed variables. They are known variables, okay. All right, so remember that there's a difference between the dependent and independent variables. One is a random variables and the other are the non-random variables. But for correlation, okay, when we deal with correlation, we will treat the two variables are as both random variables. Okay. All right. So regression analysis. When can we do a regression analysis between the variables? When? Okay. So regression analysis only can be conducted if that relationship is suggested by economic theories or the results of previous researches. Okay, as we have discussed, you cannot build a model by your own. Okay, you have to base on economic theories. You have to base on the results of previous researches to determine the dependent variables and the independent variables, and also determine the type of relationship between them in the model. Okay, but for correlation, you do not need those economic theories. You do not need the results of previous researches. You just need the data. The data will suggest the correlation relationship between the two variables. Okay, you do not need those economic theories. All right, but for regression analysis, in order to specify the model, in order to build the econometrics model, you have to do a research. Okay, you have to do a review of economic theories. Okay, to see which variables can be brought into the model. Okay, can be brought into the model. All right, that is the difference between a regression and a correlation analysis. Do you have any questions here? All right, so we will continue. Now, for the source of data, the source of data for economics and econometrics analysis, empirical economics analysis. For the type of data, we have discussed some type of data based on the structure of them. So based on the structure of the data, we have cross-sectional data, time series data, and panel data. For cross-sectional data includes the observation for different units at different points in time. At one point in time. Okay, time series data includes the observations for one unit at different points in time, and panel data include the observations for different units at different points in time. Okay, so we have some main type of data for econometric study. Okay, for different type of data, you will have different way to deal with them. For cross-sectional data, mostly we will use the method of ordinary least square to estimate the model. For time series, you will take advantage of the data by using some time series model, which you will learn in forecasting and in economics and business. For Parnell data, okay, you will use some model like fixed effects model or random effect model that you study in econometrics too. All right. So for each type of data, we have different way to deal with them. All right. For the source of data, so in the previous lecture, I have provided you with some source of the data for econometrics analysis. You can also find the some more source of data in the appendix E of the book. Okay, of the textbook, you can also find some source of data for your analysis there. All right. So, sorry, in appendix F, the data can be experimental or non-experimental. So, experimental data are usually the data that we obtain in what natural science courses, and non-experimental data are usually the data that we obtain in social science. All right. So, whether the data that we are dealing with cross-sectional time series or panel, they can be experimental or non-experimental data. There is always a problem with the accuracies of the data. All right. So what are some problems of the data? For example, we may incur observation error or measurement error in obtaining the data. Okay, for example, when we collect the data on how many times a student, okay, dispose weight at the schoolyard, for example. Okay, you stay there, you stand in the schoolyard, and then you watch people walking by, and whether they dispose some waste into the schoolyard. All right, but for example, you see that there's there are 10 times that student do the things, but when you record the number, you only record number 9. Okay, so that is an error in observations. Okay, so for experimental data, that's there's maybe some measurement approximation because of the error in the measurement tools or something like that. Okay, and also as we use different, okay, we use different sampling method in obtaining the data. Okay, that is very difficult to make to compare the result obtaining from various sample. Okay, one may do the two people may do the same topic, may do the same problems, but their result may be different, and we cannot say which one is better because their sampling method is different. Okay, and also economics variables. Economic data are usually available at a highly aggregate level. For example, most microeconomics data like GDP or inflation rate or unemployment rate are available from economy as a whole. Okay, and if the ultimate object of the research is at the individual level, okay, or at some smaller level like province level or something like that, you may not have enough data for your study. Okay, and some data are confidential. Confidential data that you cannot obtain the data for them. So as you see, because of all these problems, okay, we should keep in mind that the results of research are only as good as the quality of the data. Okay, so when you obtain the data, when you obtain the sample data, the sample must be represent, okay, the sample must represent the population. Then you will get better estimations of the problems. All right, and sometime you may not get a satisfactory result. You may see that what you get from your model is different from the economic theories that you have studied or that you have read. All right, so that may be not because your model is wrong. Okay, that may be because of the inaccuracies of the data. So when you see an unsatisfactory result, you need to explain whether that is the problem of data or whether it's the problem of the model. Okay, you have to understand your data, you have to understand your sample to determine whether the results is because of the model or because of the data. All right, that is some note about the data used for econometric study. So there's some basic things about regression analysis. All right, about regression analysis. Do you have any questions regarding the definition or some basic things about regression analysis before we move to chapter 2? Chapter 1 is quite short, all right?
Can you tell me a little bit more about the experimental and non-experimental? I really did not get that part.
Okay, so experimentals are the data that we usually obtain from natural science. Okay, then that means when we control one variables or we control many variables, and we will see the observed value of the other variables. Okay, that is the thing that we usually do in natural science. But for non-experimental variables, we do not intervene we do not intervene in the variables. Yes. Okay, we do not intervene into the situation. We just observe all the variables and collect the
Mẹ
data.
bom rồi.
Cái gì ạ? Excuse me?
Tôi đi đường đéo vào mà không nổ alarm bot nhỉ?
Trời ơi.
Hai cuối trong sai chăng? Cuối trong sai.
Dũng, tắt mic.
Dạ vâng ạ.
Ok. Đang chơi điện tử à? Học hành này thì chết. Nào. Okay.
So do you mean like non-experimental, it's for like economics analysis, and only natural science use experimental, right?
Yeah.
Thank you.
Yeah. Okay.
That leads to a question, because economics is both a social and a natural science, right? So where do we draw the line?
Economic is actually a social science subject.
But we assume a lot of things in order to calculate the parameters for it, right?
Yeah.
Some way turn it into a natural science, in my opinion. So where do we draw the line?
Okay, later you will see that when we estimate the model, we will have some assumptions about the model. But for the data that we collect, Okay, when we collect the data, we do not control any variables. All right, we just let the variable be themselves and we collect the data on them. We cannot control any variables to collect the data on them. Okay, that is called the non-experimental data. Okay, but when we estimate the model, we will have some assumptions, but those assumptions has nothing to deal with the controlling of our variables. Okay.
I'm good.
Okay. Any other questions? No. Then we will move to chapter 2. Okay. Chapter 2. Two-variable linear regression model, or sometimes we call it simple linear regression model. Okay, two variables linear regression model or simple linear regression model. Right. So before we go to we come to see how an econometrics model look like, we will make okay, tell the difference between our population and sample that we have studied in statistics and probabilities. For populations, a population is the set of entities under study, it including all the entities of interest, okay, all the observations of the population of interest, that is our population, okay, including all the entities under the study. But for sample is just a subset of the populations. For example, if this is our population, all right, the circle, if this circle is our populations, then some observation from the population, for example, these observations will form a sample. Okay, you can also take some other observation, okay, other observation, and those observation will be a sample from the population. So from one population, you can take various samples from the population. Okay. For example, when we consider the income of all households in Hanoi, our population here is the income of all households in Hanoi, every house in Hanoi. But you can take the income of 10 households from Dong Da district. You can also take the income of 10 households in Hoàng Mai district. You can also take the income of 10 households in Hoàn Kiếm district, for example, and then we will have a sample of 30 observations, and that is a sample from the population. Okay, and you can see that from one population, you can take various samples. Okay, so when we study the population, when we investigate the population, we usually want to know the characteristic of the population. Those characteristics is often expressed by the parameters of the population. Okay, for example, last time we have discussed this. What is the average income of all households in Hanoi or the Mui? Okay, and how scattered the income are among the household or the variance of the populations. Okay, we want to know the mean, the population mean, and the population variance of the population that we are interested in. Okay, but sometimes we cannot collect the data of the whole population because in practice the population is usually a very large one. Okay, you cannot collect the data of all the observations. Okay, that's why usually we collect a random sample and get an approximations of the parameters that show the characteristic of the population. Okay, and here you can see the relationship between population and sample here. Population with some parameters like the number of observations, big N, the population mean, and the population variance. Those are the parameters of the population. Okay, and from the population, we take a random sample. Take a random sample, and we for the sample we calculate the sample mean x bar, okay, and the sample variance s square, and then from those this thing we call the sample statistic, okay, and from the sample statistic we will go back to estimate and do hypothesis testing about the population parameters to get a better or closer understanding of the population parameters. Okay, we cannot calculate the exact value of those population parameters. We just get an approximation of them by using the information, using the statistic that we get from the sample. Okay, and that process is called the statistical inference that we talked about in the previous lectures. Okay, so you can, in econometrics model, we also have population regression model and sample regression model. Okay, so what is the difference between them? Okay, what is our ultimate goal in doing a research? Okay, and what is a regression model? Okay, we will find it out here. All right, so we have population regression model and sample regression model. Okay, firstly, we see that they have the common thing, that regression model. So what is a regression model? Okay, a regression model is usually a rule or an equations, a mathematical equations that show the dependencies of the dependent variables on the independent variables. Okay, so regression model is usually a rule, often they are often expressed in mathematical equations. Okay, and that equations show the dependencies of the dependent variables on the independent variables. And population regression model, okay, population regression model is the rule or the principle that applied for the whole population of interest. Okay, and the population regression model can be drawn using all population observations. All right, okay, so for one population, remember that for one population, you only have one population regression model. Okay, and how about the sample regression model? What is the difference between population and sample regression model? All right, for sample regression model, it is also a rule, okay, a mathematical expression or mathematical equations that show the dependencies of the dependent variables on the independent variables. Okay, but that rule is only applied for a specific sample. All right, so it means that for one sample you will have one sample regression model, but for a populations, for one population where you can take various sample from the populations, then you will have different sample regression model for one research. Okay, all right, population regression model, there's only one population regression model, but you may have many or different variety of sample regression models. Okay, and sample regression model can be drawn using the observation from a specific sample. Okay, population regression model applied for the whole population of interest, but the sample regression model, okay, applied for a specific sample taken from the population. All right, that is the difference between population and regression and sample regression model. All right, any questions here? Okay, next. So why do we have, what is the ultimate goal? Okay, what is the ultimate mm, up, what is objective? What is the ultimate objective of a research? The population characteristic or the characteristic of a sample? Can you answer me? What is the ultimate objectives of a research? The characteristic of the whole population or the characteristic of a specific sample? Khi mà các bạn nghiên cứu thì các bạn quan tâm đến cái đặc điểm của tổng thể nói chung hay là cái đặc điểm của mỗi một cái của một cái sample nhất định nào đó?
The population.
Okay. Yep, the population as a whole. Okay, we care about, we want to know the characteristic of the whole population. We want to know the rule that applied for the whole population. Okay, so why do we have to use sample regression model? Why do we need the sample regression model? Because the sample regression model only show the rule, okay, or the equations that applied for a specific sample.
Because we don't have enough resources to estimate the whole population.
Yeah. Because we do not have enough data, right, to estimate or to calculate exactly the rule for the whole populations. Okay, that's why we have to use the statistic that we get from the sample here, or the characteristic of the sample regression model that will help us to estimate the characteristic or to make inference about the rule or the relationship between the variables in the population. Okay, so sample regression model here is not the ultimate goal. Okay, it's just a mean, okay, a mean that brings us closer to the population regression model. All right, so in order to get a good estimations of the population regression model, our sample must represent the population. Okay, the sample must be the representative of the population. Then the statistic, okay, the characteristic of the sample can be used to make inference about the population regression model. Okay, so when a sample represents the population, so it depends on on the sampling method that you use to acquire the data. Okay, it depends on the sample size as well. The bigger the sample size, the more representative the sample is. Okay, so remember, when you collect the sample data, you must the sampling methods must be a random sampling method. Okay. All right, now let's look at the population regression function to see how it look like. In order to illustrate the population regression function, I will take a hypothesis, assume what hypothetical, okay, hypothetical population, that is 40 household in a community. Okay, example, we want to regress the weekly consumption Y on the income X to see the dependence of household consumptions on their income in a community of 40 households. Okay, so the population here is only 40 households. So it's easy to get the information, to get the data, to get the observation of the whole population. Okay, it's just a hypothetically population. In reality, our population is usually much bigger. All right. So because the population is quite small here, then we can easily get the data, the observations of the whole population. So X is the level of income and Y is the level of consumptions. Okay, we have 40 observation here. For one level of income, you can see that there's a statistical relationship between X and Y. Okay, for one level of income here, different household will have different level of consumptions. For example, when the income of is $80, then one household has the consumption of $55, another has the consumption of $60 per week. Another one has the level of consumption of $65 a week. Okay, the same happens when the levels of income is $100 per week. Okay, and so on. We have 40 observations here. All right, the relationship between X and Y is statistical relationship. But now look at this. For one level of income, we only have one level. We have only one conditional mean of Y. Okay, do you remember the conditional mean or the conditional expectation?
Yes.
Okay, the conditional expectation. We have different value of Y, but we only have one conditional expected value of Y in the case that X is equal to 80. Okay, that is 65. For the case, okay, for the situations when X equal 100, we have different value, observed value of Y, but we only have one conditional expected value of Y, that is 77. Okay, and the same happen when X equal 120 and so on. Okay, we have for each value of X, okay, for one value of X, we only have one conditional expected value of Y. All right, so based on this relationship, we can build the population regression function as a function between X and the conditional expected value of Y. All right, now here, this is called the population regression function. Okay, it is a function of cost, okay, a function of cost, and it's so the functional relationship or the deterministic relationship between X and the conditional expectation of Y. All right, can you see that? Okay, we have the conditional expected value of Y, okay, the expected value of Y given on the value of X is a function of the variable X, okay, and in this case, when we express the relationship between income and consumptions, we can use linear functions to express the relationship between them. Okay, so we have the conditional expected value of Y, okay, equal beta 0 plus beta 1 times the observed value of X. Okay, so remember that we have a difference in notation here with the textbook. The textbook begin with beta 1, and here to make it consistent with econometrics 2, okay, because the teachers that teach you econometrics 2 will use the notation of beta 0 here, so I will also use the notation of beta 0. We start with beta 0 here, okay, but the other things is not different. Okay, all right, so we have the conditional expected value of y is equal to beta 0 plus beta 1 multiplied by xi, okay, where x is the independent variables, okay, and in this case is the level of income, and y here is the dependent variables. Expected e and y and x here, this one is the notation for the conditional expected value of the dependent variables, and in this case is the conditional expected value of the expenditures or the consumptions. Okay, beta 0 and beta 1 here are called the parameters. Okay, beta 0 and beta 1 are the parameters of the population regression function. Okay, and beta 0 is the constant or the intercept, and beta 1 is the slope. Okay, and beta 1, so the effect of the independent variable x on the conditional expected value of y. Okay, this one, the slope, though the shows the direct effect of the independent variable x on the conditional expected value of y. Okay, so this one is called the condition, called the population regression functions. Okay, and it shows the functional or the deterministic relationship between x and the conditional expected value of y. However, you can see that the relationship between x and y, the two variables, is statistical relationship. That's why we have another way to express the population regression model. That is the stochastic specification, the stochastic form of the population regression model. Okay, this is the stochastic form. We have the observed value of y. Now, not the conditional value of y, but the observed value of y here is equal to the expected value of y, okay, the conditional expected value of y, this one. Okay, this one is the conditional expected value of y. So the observed value of y is equal to the sum of the conditional expected value of y and a term that we call it the disturbance. Okay, the disturbance ui. All right, so the disturbance ui represent other factors that affect the dependent variables other than the independent variable mentioned in the model. Okay, so here in the model, you can see that we say that x, okay, may explain the value of y, but beside x, there's a lot of other factors that affect the value of the dependent variable as well. Okay, and ui here will represent the effect of those factors. Okay, all right. So here is called the stochastic form of the population regression model, and this one allow the statistical relationship between x and y. Okay, this one show the deterministic relationship between x and the conditional expected value of y. Remember that. Okay, so the population regression function, okay, shows the deterministic relationship between x and the conditional value conditional expected value of y, okay, and the stochastic form, okay, the stochastic form of the population regression model shows the statistical relationship between x and y. Because of the disturbance, the error term here, it is also a stochastic variables, and because of that, for one level of x, okay, we can have different value of y. Because the value of y also depends on the random term, that is the disturbance. Okay, all right. So if you write, if you can see that we have two ways to express the population regression model. That is the population regression functions and the stochastic form of the population regression model. All right. And remember that for the population regression function, there's no UI here, okay? No UI here, because the relationship between x and the conditional value of y is a deterministic one. For the stochastic form of the population regression model, we must have UI here. We must bring UI into the model because UI allows the statistical relationship between x and y. In the stochastic specification, we demonstrate, we illustrate the relationship between x and y, not the relationship between x and the conditional expected value of y. Okay, that's why you have to have UI here to allow the statistical relationship between x and y. So remember that to write the then you can write the right form of the population regression model. Được chưa? Dạng nào phải đúng dạng đấy nhé. Chỗ này cô đặc biệt phải nhắc các bạn này. Dạng nào phải đúng dạng đấy. Với cái thằng có hai cách viết. Cách thứ nhất là cái population regression function này. Được chưa? Và cái dạng thứ hai nữa là cái dạng stochastic form, cái dạng ngẫu nhiên của cái mô hình hồi quy tổng thể. Đúng không ạ? Thì với cái conditional với cái population regression function này thì nó thể hiện cái deterministic relationship. Vì vậy cho nên là không có UI ở đây. Được chưa? Không có UI ở đây. UI nó cũng là một cái thằng random, cũng là một cái thằng stochastic nhé. Được chưa? Thế thì bởi vì x và cái conditional expected value of y nó là một cái deterministic relationship. Vì vậy cho nên là nó chỉ là một hàm số thôi và nó không có UI ở đây. Được chưa? Phải viết đúng cái dạng này. Còn nếu như các bạn viết cái dạng là cái dạng stochastic form thì bắt buộc các bạn phải có UI, không thể thiếu UI được. Nếu như thiếu UI là các bạn sẽ làm sai mất cái mối quan hệ giữa x và y. Đúng không ạ? Mối quan hệ giữa các cái biến kinh tế của chúng ta là quan hệ thống kê chứ không phải là deterministic relationship. Đúng không ạ? Vì vậy cho nên là gì ạ? Nếu như các bạn thể hiện cái mối quan hệ giữa x và y thì bắt buộc các bạn phải có cái thằng UI này. Đúng không ạ? Còn nếu như các bạn bỏ mất UI là các bạn đã thể hiện sai cái mối quan hệ giữa các cái biến kinh tế. Được chưa ạ? Vì vậy cho nên là có hai cách viết như thế này. Viết dạng nào thì phải đúng cái dạng đấy. Được chưa ạ? Nắm được chỗ này chưa? Có câu hỏi được không? Any questions here?
No.
Okay, good. Alright. Thì các bạn nhớ là gì ạ? Một cái nữa mà cô lưu ý ở đây. Cái population regression functions. Ở đây, cái này gọi là cái functional form. Đúng không ạ? Cái này là functional form của nó. Thì functional form nó có rất là nhiều dạng. Đúng không ạ? Sau này các bạn sẽ học nhiều dạng nữa. Ở đây lại hiện tại là cái bài mở đầu, cho nên là cái bài đầu tiên, cho nên là cô cũng chúng ta cũng tìm hiểu cái functional form nó đơn giản nhất, đấy là cái linear. Đúng không ạ? Cái linear function. Đúng không ạ? Sau này chúng ta sẽ có rất nhiều như là quadratic function hay là cubic function hay là logarithm function, đúng không ạ? Ví dụ vân vân và vân vân. Thế thì nhớ là gì ạ? Cái function này để mà determine được là nó là cái dạng function nào thì chúng ta sẽ phải dựa vào các cái yếu tố, dựa vào các cái lý thuyết về mối quan hệ giữa chúng nó, đúng không ạ? Hay là dựa vào các cái nghiên cứu đi trước để chúng ta xác định cái functional form ở đây. Được chưa? Còn ở trong cái bài này, ở trong cái ví dụ này thì cái functional form mà các bạn có thể lấy ở đây thì đơn giản nhất là cái linear function này. Được chưa? Đó. Rồi, ok. Now, let's take a 20-minute break, and then we will come back and continue our lecture. All right. Okay. Take a 20-minute break. Have you come back?
Yes.
Okay, good. Now let's continue with our lecture. So we have just discussed the population regression. We have two ways to express the population regression model. That is the population regression function and the stochastic form of the population regression model. Okay, and remember that for the stochastic form, we have to have the disturbance UI in our model, right? So come back to our example of income, the relationship, the impact of income on consumptions of 40 households in a community, then you can see that for each spot here, X point in the coordinate system here will represent one observations of X and Y, okay? So for example, for when X equal to 30, okay, we have different observed value of Y. So the gray points here are the observed value of Y corresponding to the observed value X of 80. When X is equal to 100, we also have different observed value of Y and so on. But for one value X, we only have...
We're not seeing the slides.
Okay, sorry. Okay, right. Okay, so for one value of X, you can have different value of Y. The gray points here represent the observed value of Y. Okay, for one value of X, different observed value of Y. Okay, but for one value of X, we only have one conditional expected value of Y, that is the red points. Okay, and then when we connect the red point, it will form the, we call it the population regression line here, and this one will show the rule or the principle or the relationship between X and the conditional expected value of Y for the whole populations. Okay, that is called the population regression line, connecting, okay, all points lies into the line on the population regression model represent the conditional expected value of Y. Okay, and the observed value of Y can vary, okay, can varies from the mean, okay, like this. It may be or may not line on the population regression model. Okay, so in the stochastic form of the population regression model, you can see that we have two parts here. The first one is the conditional expected value of Y, and the second one, disturbance. Okay, and we call the conditional expected value of Y is the systematic component, and the UI here, the disturbance, is the non-systematic component. That is, it is may have this UI, okay, may affect this observation, another observation, but as a whole, it does not affect the whole population. Okay, in some minor observations, the component, the non-systematic component UI here may affect this one a little bit, this one a little bit, but for the whole, okay, for the whole population, the non-systematic component does not affect the value of the the dependent variables. Okay. Okay, and this is called the systematic or deterministic component. It is determined by the observed value of X and the parameter, the constant parameters of the model. Okay, this is unchanged, this is deterministic for one value of X. Okay, so why do we have the disturbance UI in the model? So the disturbance UI, sometimes we call it the error term. Okay, the error term. As we say that it represents other factors that affect the value of the dependent variables. Okay, so why don't we bring all the other factors that affect the value of the dependent variables into the model? Why? Why not? Why not bring them into the model? There's a lot of plenty of reason for not bring those factors into the model. The first one is that sometimes we are ignorant about the variables that affect the value of y. Okay, so we know that from the economic theories or from the results of previous researchers, we may find some variables that affect the value of y. Okay, but there may be some other variables that also affect the value of y that we does not know about them. Okay, and because it is not because we do not know about them. Okay, we do not know about them. It doesn't mean that it does not affect the value of y. Okay, so that's why we cannot bring all the variables that affect the value of y into the model. Maybe we do not know about the appearance of that. Okay, sometimes when we know that, okay, so there are some variables like this, okay, affect the value of y, but we cannot obtain the data, the observed data for those variables. Okay, and without the data, you cannot bring those variables into the model. Okay, that is the second reason. And another reason is because of the randomness of human behavior. Okay, today I'm happy, so I will work out and I work out and I spend a lot of money. I watch movie. I bought I buy so much things and so on so on. Okay, but another day I also feel happy. I am also happy. Okay, but I don't want to go out. I just want to stay at home and watch a movie or something like this. All right, that is the randomness in the human behavior, and it is very hard to measure this randomness. So, because we cannot measure the randomness in human behavior, we cannot bring it into the model. Okay, so remember something that you want to bring to into the model, you have to you have to be able to measure it, or you have to be able to quantify it. All right. Okay, so another reason is that we want to keep our regression model as simple as possible. Later, when we deal with multiple regression model, you can see that there's a lot of other problems arise for multiple regression model. So as there are many variables, as there are more variables in the model, there will be much more problems in our model, okay, that we have to deal with. And sometimes because we use the wrong functional problems, then there will be some missing we will miss some important variables. So those variables, the effect or the impact of those variables will be represented by the disturbance UI. Okay, for example, if the right functional form is a quadratic function. For example, we have y equal to a quadratic function of x. But when we construct the model, when we build the model, we only use a linear form. Okay, a linear functions of the relationship between x and y. Then the variable square x will be omitted from the model. Okay, and the effect of square x will be reflected into the disturbance UI. Okay, so that's why we have UI in our stochastic form of the population regression model. All right, because beside the independent variables that we mentioned in the model, there are a lot of other factors that affect the value of the dependent variables. Okay. All right. So this an example. This the figure. Okay, the figure of the population regression model. Okay, we call this the population regression line. Okay, those blue points are the observations corresponding to one value of x and one value of y. For example, okay, beta zero in the model is the intercept, okay, or the intercept, or we call it the, what is it? I'm estimated. And beta 1 is the slope of the line. It reflects how y change, okay, with regard to one unit change in the value of x. Okay, UI here. So every point in the population regression line here, as we say, represent the conditional expected value of y. Okay, and each point here represents the observed value of x and observed value of y. Now consider, sorry, I have a phone call. Please wait a minute. Okay, so let's consider one observation here. For example, this one. You trace back to the lower, you can see that this is the observed value of x. And to the left, you can see that this is the observed value of y. Okay, the intersection between this one and the population regression line here is the conditional expected value of y. UI here is the difference between the observed value of x and is the difference between the observed value of y and the conditional expected value of y. Okay, so UI can be positive, like in this case, and UI can also be negative. For example, this case. Okay, all right, and what else? Okay, and that's all we can talk about the population regression model. All right, it can be a line like this. It can also be a curve or something like this. Okay, it depends on the functional relationship between x and y. Next, so that is the case, okay? That is the case when you can collect the data. You can collect the data of the whole populations. And in that case, you can identify you can exactly identify the population regression line, okay? But most of the time, you do not you cannot obtain the data of the whole population. We can only take a random sample from the population. And in that case, you can only identify a sample regression function. Okay, so sample regression function, what is it? Sample regression function has the same functional form as the population regression model. So the population regression model is the rule that applied for the whole population. So sample taken from that population will also follow that rule. So it means that if the population regression model has a linear form, okay, then the sample regression function will also has we also have a linear form as well. Okay, so the form of the sample regression function will be the same as the form of the population regression model, but the way that we express it is different. Okay, so in the case we only obtain sample data, we can only construct the sample regression function, identify the sample regression function. So here is it is called the sample regression function, this one. Okay, this one is called the sample regression function. Okay, this one is called the sample regression function. All right. Okay, this one is called the estimated value of y or the fitted value of y. Okay, y hat the fitted value of y, or the estimated value of y. Okay, anything that has a hat over it mean that is an estimator. Okay, a variables with a hat over it, is understand as an estimators of the value of the thing that do not have a hat over it. Okay, for example, beta 1 hat, beta 0 hat is an estimator of beta 0. Okay, beta 1 hat is the estimator of beta 1. All right, and yi hat is the estimator of the conditional expected value of y, and later we will also use yi hat as the estimator for the observed value of y as well. Okay, all right, so that's why we call it the fitted value of y or the estimated value of y. All right, so this is called the sample regression function. All right, we have ui hat. Remember that the difference from the population regression function is that here we have ui hat equal not beta 0 but beta 0 hat plus beta 1 hat multiplied by the observed value of x. Okay, and also like the sample regression model, like the population regression model. So the sample regression model also has a stochastic form. Okay, the stochastic form also show the statistical relationship between x and y in a sample. Okay, in a sample for one value of x, you can also observe different value of y, right? And that's why we have the stochastic form of the sample regression model. That is, we have the observed value of y in the sample equal the fitted value of y. Okay, the observed value of y in the sample equal the fitted value or the estimated value of y plus a component that we call it the residuals of the model. Okay, the residuals of the sample regression model. Okay, it's not ui anymore, but it's ui hat. Okay, ui hat, and as you see, it is a hat over it. So ui hat is the estimator of our ui. Okay, so in the case when you do not have enough data for the whole population, you can only specify the form of the population regression model, but you cannot calculate the exact value of beta 0, beta 1 in the population regression model, right? And that's why you have to estimate it. Okay, So in the case when we do not have, okay, we do not have the data, for population, for the whole population. Okay, you can just identify the specification. You can just build the specification of the population regression model. That is, for example, the conditional expected value of y given on x is equal to beta 0 plus beta 1 multiplied by x, for example. Okay, but we do not know, you cannot calculate the value of beta 0 and beta 1 because you do not have the data for the whole population. Okay, but we want to know about beta 0 and beta 1 to understand the relationship between x and y in the whole population. Okay, but that's why we have to estimate them. We have to estimate beta 1 and beta 0. And how can we estimate them? We have to take a random sample and calculate the estimators for beta 1 and beta 0 here. And those estimators are beta 1 hat and beta 0 hat. Okay? And here, because you don't know the value of beta 0 and beta 1, so ui here, and you cannot understand, you cannot know the exact value of the conditional expected value of y. And ui equal is the difference between the observed value of y and the conditional expected value of y, right? Okay, but you may have the observed value of y, but we do not know the exact value of the conditional expected value of y. That's why you cannot identify the exact value of ui as well. Okay, so we know that for each observation, there is an error, there is a disturbance there, but we do not know the exact value of the disturbance. All right, and that's why we also have to estimate the disturbance ui here. And the estimator of ui is this one, the residuals. Remember that. So in the sample regression model, you only have the residuals, not the disturbance. Okay, disturbance only appears in the population regression model, and it represents the difference between the observed value of y and the conditional expected value of y. But residuals only appears in the sample regression model, and residuals is different. Residual ui hat here is the difference between the observed value of y and the estimated value of y. Okay, and the estimated value of y, or the fitted value of y, not the conditional expected value of y. Okay, so remember the difference between the residuals ui hat and the disturbance ui. They are two different things. Okay, and beta 0 hat and beta 1 hat are also different from beta 1 and beta 0. Okay, they are sample statistic. Beta 0 hat and beta 1 hat are sample statistic, but beta 0 and beta 1 here are population parameters, unknown population parameters. But for beta 0 hat and beta 1 hat, you can calculate it. Yeah, you can calculate it using mathematical tools, because we have the data of all the data of the sample, right? We can have all the data of the sample, and based on those observations, you can calculate the exact value of beta 0 hat and beta 1 hat. Okay, so how can we do that? We will maybe in the next lectures, we will talk about how to calculate the exact value of beta 0 hat and beta 1 hat. All right. Next. So we talk a lot about linear regression model. Okay, so how can we understand the term linearity, okay, linearity in the linear regression model? Okay, how can we understand that? So as we see that we have two components of a model, okay, the parameters and the variables. So when we say that one model is linear, okay, the model is linear, we can there's two ways that we can understand the linear term here. It means that the model is linear in the parameter, and it can also be it can also be understand that the model is linear in the variables. Okay, so what is linear in the parameter, and when we say a model is linear in the variables? So look at this. We have two cases when the model is linear in the variables. Here we have yi and xi has the power of 1. Okay, has the power of 1, and you can see that we can draw a line to show the linear relationship between x and y. Okay, so that is the case when we say that, okay, so this model is linear in the variables. Okay, all the variables, or the independent variable here is also okay. The independent variables has the power of 1. Okay, but when we say that a model is linear in the parameters, then the independent variables does not need to have the power of 1, but the parameter have to have the power of 1. Okay, like this model, we have yi equal beta 0 plus beta 1 multiplied by x 1 over x, which is x with the power of -1, okay, and plus ui. This model is linear in the parameters, okay, but it is not linear in the variables. Okay, this model, the upper one, is linear in the variables, but it is not linear in the parameters because beta 1 has the power of 2. Okay, so for the model that we are considering here, okay, we have the conditional expected value of y is equal to beta 0 plus beta 1 multiplied by x. So x has the power of 1, and beta 1 has also have the power of 1. Then this model is linear in both the variable and the parameters. Okay. So in econometrics, the when we say that a model is a linear regression model, it means that that model is linear in the parameters. Okay. In econometrics, when we say that one model is a linear regression model, it means that that model is linear in the parameters, which means that the parameters of that model must have the power of 1. Okay, so that is because of the some estimation method in econometrics. So econometrics divide the model into some category, and one category is the linear regression model. And in the category linear regression model, all the model must be linear in the parameters. Okay. Okay, so then you will see that with linear regression model, we can use the ordinary least square estimation method to estimate those models. Okay, that's why econometrics divide the model into different categories like that. Okay, and remember that for linear regression model, okay, those linear regression model have to have the parameter with the power of 1. Okay. Nhớ là linear regression model tức là các cái mô hình mà có tham số mang bậc 1, đúng không ạ? Variables, các cái biến không cần mang bậc 1 ạ, chỉ cần tham số beta mang bậc 1 thì đấy được coi là các cái linear regression model, đúng không ạ? Và như vậy thì các cái linear regression model này có thể thể hiện được rất nhiều các cái mối quan hệ giữa x và y khác nhau, có thể là mối quan hệ tuyến tính linear relationship, cũng có thể là các cái mối quan hệ non-linear relationship giữa x và y như là quan hệ bậc 2, bậc 3 hay là log hay là nghịch đảo vân vân và vân vân, đúng không ạ? Thì các bạn lưu ý rằng ở đây là gì ạ? Linear regression model thì chỉ cần là linear in the parameters mà thôi, được chưa? Đó, và tất cả những cái linear regression model này thì nó đều có thể ước lượng được bằng một cái mô hình mà chúng ta gọi, đều có thể ước lượng bằng một cái phương pháp ước lượng mà chúng ta gọi nó là cái ordinary least square OLS method, đúng không ạ? Và cái nội dung của cái OLS estimation method này ấy, đúng không ạ? Thì chúng ta sẽ học ở cái, chúng ta không biết có đủ thời gian không? Thực ra bây giờ cũng là 11:30 rồi, đúng không ạ? Vì vậy cho nên là cô nghĩ là cái phần này thì chúng ta sẽ để lại ở phía sau, đúng không ạ? Chúng ta sẽ để sang cái bài hôm sau thì chúng ta sẽ học về cái mà chúng ta nói ở đây, đó là cái ordinary least square estimation method, đúng không ạ? The way that we use, đúng không ạ? The method that we use to estimate the sample regression model. Okay, then the way that we use to not estimate but to specify the sample regression model. Okay, we estimate, remember that we estimate the population regression model. Okay, and we specify the sample regression model. All right, and this method we will leave it to the next lecture. Now, as you have formed your own group, right? Please begin to think about a model, a two-variable regression model. Okay, that you can specify the population regression model and try to find some data. Okay, for the variables in that population regression model. Later, okay, on next lecture, on next class, we will use those data to estimate your model. Okay, now each group, think of your own population regression model. What can be the dependent variables and what can be the independent variables, and why do you choose the variables to bring into the model? Okay, then express the relationship between them by the population regression model. Okay, then try to find the data for the variables in the model. Okay, nào, bài tập về nhà nhé, là một cái work ở nhà với cái group work của các bạn ạ, đúng không ạ? Các bạn hãy về nhà này, nghĩ cho cô một cái mô hình, đúng không ạ? Chúng ta hãy nghĩ về các cái biến kinh tế, các cái economics variable chẳng hạn, đúng không ạ? Rồi các bạn thử nghĩ cho cô về các cái biến đó này. Rồi có biến nào có thể làm cái dependent variables và biến nào thì có thể làm cái independent variables, đúng không ạ? Và sau đó chúng ta sẽ xây dựng cho cô một cái population regression model giữa hai cái thằng biến này, thể hiện cái mối quan hệ giữa hai cái thằng biến này, nhưng mà như chúng ta đã học, đúng không ạ? Và các bạn cố gắng giúp cho cô một việc, đó là gì ạ? Tìm cái số liệu, đúng không? Tìm cái số liệu cho các cái biến đó, đúng không ạ? Để sau này chúng ta có thể sử dụng nó để estimate cái mô hình của chúng ta, được chưa ạ? Và một cái điều nữa mà cô nhắc đó là gì ạ? Khi mà các bạn lựa chọn biến, nhớ là gì ạ? Khi lựa chọn các biến vào trong mô hình, các bạn phải dựa vào các cái economic theories hoặc là cái results of previous researches, được chưa? Phải dựa vào cái đó để các bạn xác định các cái biến. Sau này khi mà cô hỏi các bạn tại sao các bạn lại lựa chọn biến như thế này thì các bạn cần phải giải thích được, được chưa? Các bạn căn cứ vào đâu, các bạn dựa vào đâu để các bạn lựa chọn các cái biến như thế, được chưa? Đó, các bạn đã nắm được chỗ này chưa ạ? Có câu hỏi gì không? Any questions?
Nhóm ở đâu ạ?
Các bạn tự form nhóm mà. Cái này nó sẽ đi kèm với cái group work giữa kỳ của các bạn luôn đấy ạ. Các bạn có thấy cái group work của chúng ta không ạ? Đúng không ạ? Thì thay vì bây giờ đến cuối cùng các bạn nộp cho cô một cái bài group work thì chúng ta sẽ đi từ từ dần dần theo từng các bài và các bạn sẽ form cái group work đấy. Bây giờ các bạn sẽ nghĩ đến một cái topic nào đó các bạn quan tâm, đúng không ạ? Các bạn quan tâm đến cái vấn đề gì, đến cái mối quan hệ giữa các cái biến kinh tế nào đi chẳng hạn, đúng không ạ? Rồi, trước hết là nghĩ cho cô về biến phụ thuộc và một cái biến độc lập đã. Đúng không ạ? Biến phụ thuộc, cái dependent variable và một cái biến independent variable đã. Cơ sở ở đâu để các bạn lựa chọn các cái biến đó. Được chưa ạ? Và sau đó là gì ạ? Xây dựng cho cô cái mà chúng ta gọi là cái population regression model từ hai cái biến đó. Được chưa ạ? Và đi tìm các cái số liệu cho các cái biến đó của chúng ta. Đó. Đấy thì nó sẽ, cái group này là nó sẽ theo cái group work giữa kỳ của các bạn đấy ạ. Hôm trước cô đã dặn các bạn là về là chúng ta thành lập nhóm chưa?
Chưa ạ.
Rồi ạ.
Rồi ạ.
Rồi. Trong cái bài mở đầu khi mà cô nói về cái evaluation ấy, evaluation chúng ta có cái group work là 30% đó. Đó thì khi đó các bạn cần phải làm cho cô một cái nhóm, đúng không ạ? Chúng ta là một cái nhóm. Một nhóm thì có nhiều nhất là 5 thành viên, đúng không ạ? Một nhóm có nhiều nhất là 5 thành viên thì các bạn sẽ về nghĩ cho cô, đúng không ạ? Tập hợp lại các nhóm với nhau và nghĩ cho cô về cái điều đó, đúng không ạ? Tí nữa thì cô sẽ tạo một cái link ở trên lớp của chúng ta, một cái Excel. Các bạn sẽ vào trong đó và điền cho cô điền cho cô thứ tự các nhóm 1, nhóm 2, nhóm 3, nhóm 4 vân vân và vân vân. Thành viên, các thành viên ở trong nhóm, rồi thì mã số sinh viên của các cái thành viên ở trong nhóm. Được chưa ạ? Và sau đó thì các bạn có thể điền ở bên cạnh cho cô đó là cái topic mà các bạn quan tâm, đó là cái topic nào, đúng không ạ? Và các bạn nghiên cứu cái mối quan hệ giữa các cái biến nào chẳng hạn, đúng không ạ? Đó, thì tí nữa cô sẽ lập một cái Excel ở trong cái team của chúng ta, và các nhóm sẽ giúp cho cô điền các cái thông tin vào trong đó. Được chưa? Về các bạn sẽ nghiên cứu cho cô nhé, nghiên cứu cho cô một cái mô hình, đúng không ạ? Nghĩa cho cô bây giờ tôi quan tâm đến cái topic nào, thế thì cái biến phụ thuộc có thể là biến nào, biến độc lập có thể là biến nào, cái lý do, cái cơ sở ở đâu mà các bạn lựa chọn các cái biến đó để đưa vào trong mô hình, đúng không ạ? Và sau đó là xây dựng cho cô cái population regression model và cố gắng là đi tìm số liệu và đi tìm số liệu cho các cái biến đó. Được chưa ạ? Và hôm sau chúng ta sẽ có một cái phần đó là estimate the model, đúng không ạ? Và sau khi học xong cái kỹ thuật estimate the model thì các bạn có thể sử dụng cái số liệu đó để các bạn estimate cái mô hình của các bạn. Được chưa? Ok.
Can you explain it in English again?
In English?
Yes, the group work.
Okay.
Or you just explained.
So the group work, we have at most 5 students in a group. Okay, so as you have learned about the two variable regression model, then at home please think of an interested a topic that you are interested in. Okay, think of think of the dependent variables and the independent variables that can explain for that dependent variables. Okay, and please show the reason. Okay, please speak the reason why you choose those variable to bring into the model. Okay, after you have specified the variables that you want to bring into the model, okay, you will form a population regression model between these two variables, okay, and try to find the data for those variables. And in the next lecture, after we have learned the estimation method, you will use those data to estimate your model. All right.
Okay, thank you.
All right. Any other questions? All right. So our lecture ends here today. See you next week. All right. Goodbye.
Goodbye, teacher.
Bye.
Goodbye.
Bye. Thank you for your
Bye.
listening. Bye
Em chào
bye.
cô.
Ok, chào các bạn.
Goodbye, teacher.
Bye bye.
Goodbye, teacher.